Hi. Okay. Good morning, everyone. Also from my side. Fantastic to be back at Rutgers. I have been here a PhD student a couple of years ago. It feels a little bit like coming home these days. Yeah, I think I had my kind of old alma mater. Yeah, my name is Marco. I'm an auditor at the Swiss Federal Audit Office, which is the national audit office in Switzerland, or the Swiss Supreme Audit Institution. And it's my great pleasure today to present you some of the work that we are doing together with colleagues at Rutgers and also with my former colleagues at the International Computer Science Institute at UC Berkeley. And what I'm trying to do in the next 40 minutes is to show you some ideas in the field of artificial intelligence, agentic auditing, which Eric also this morning mentioned. The agentic AI is one of the next major probably directions where AI is heading. We also see that in the Bay Area, that a lot of big tech companies actually are focusing. Right. So apologies up front. I think a lot of the things that I will show you are a little bit cutting edge. So we will use Google-Colab to its edge. So we might run into some errors and we'll deliberately decide to ignore them. So bear with me. Hopefully at the very end, I can show you some cool examples about agentic AI in the audit process. So what I'm trying to do, or what we want to implement today is really the idea of maybe implementing agentic journal entry testing. So what we want to do is, according to the International Standards on Auditing, 240, we want to identify anomalies in a database that maybe are not in compliance with some organizational guidelines or rules. And we want to implement it in a way that we have 3 different audit agents. One agent will mimic a senior auditor. Another agent will mimic a senior IT auditor. And the third agent will be the audit manager. And they are all collaborating in this process in order to come up with an audit report that, actually reports on the results of the agentic journal. Again, this is a mock example that we're trying to accomplish, but of course you can think about the potential and what happens if you start scaling this up. That's the idea of this tutorial. What we'll also use are 2 different libraries in the space of generative AI or agentic AI. One big application that we're using is Ollama, which allows us, and that's very important for us as an audit institution, to download, for example, LLMs into our premises so that we can use them in a privacy-preserving manner. So we're not sending information over an API. We have the models at our laptop. And that's nowadays quite straightforwardly possible if you're using, for example, an application like Ollama. Maybe a small question to you guys. Who of you is using Ollama already in this organization? Yes, in Max? Oh, should I turn off that? Another library that we're also using is AI, which is a framework that allows you to build up AI agents and train them in a way or use them in a way so they start to collaborate with each other. So this is the second framework or library that we're using. Maybe again, the question, who of you is already using AI? It's used slowly and emerging in a lot of organizations. Okay, cool. Then let's have a look into that. I think then it's probably quite interesting what I'm hopefully presenting. Okay, the first step that I want to ask you to do is, if you want to follow along the presentation and also maybe execute the different agents yourself, I set up a GitHub repository, which is available via this link over here. So if you would navigate to this link, then you should see a page that looks very similar to the one that I'm showing next here on the image. And this page has 3 buttons. I provided the notebook in 3 different versions. The first notebook is the binder notebook, which you can see here. Let me navigate to that, which is this one here. So this one is a notebook that can be used locally at your machine if you have a large language model deployed at your local laptop. But that's not what we're going for today. We want to go for the Google-Colab Notebook, which allows you to execute the notebook in the Google-Colab Cloud, very similar to what Harry was showing before. So that's what we are looking for. Okay, let me do that. So I will also navigate to this repository. So you should hopefully see it here. And I will also try to make this a little bit larger. So again, what are we trying to achieve is we want to implement this agentic journal entry testing workflow, implementing these 3 different AI agents. One thing that you also might like to do, because we will use large language models as the brain of these 3 individual agents, we want to change the setting of the Colab environment a little bit by going to the notebook settings. And then we want to use a hardware accelerator, for example, a GPU, and attach it to the notebook, which allows us to inference significantly faster when using these large language models, and not just the CPUs that are available in the notebooks usually. Okay, so let's do that. Disconnect and restart the runtime. And then hopefully it takes a couple of seconds or minutes until we have a new runtime here with a GPU attached. All right, once we have the runtime available, we'll go into the notebook, and then we'll start executing the different cells of the notebook. Again, what I will do, I mean, this notebook is available on GitHub, so it will stay there for the next couple of months, so I will not delete it. So feel free to always come back to the notebook and try it yourself, maybe at home, while you have a little bit more time. And of course, I'm happy to answer questions afterwards, so it's no problem. So you can also just see and enjoy it here. There's no need to run it in parallel. It would stay and remain. So what we'll do in the first step, we're importing quite some libraries that we need in order to build our agentic journal entry testing workflow. So there are a couple of libraries here. I'm not jumping into the details because in the interest of time, but I added a description for each of the library that we're using here. So we'll execute the first notebook, and hopefully I'm looking trustworthy to you while you are executing the notebook, and you can say, okay, I'm running it anyway. Okay, so now we have imported a lot of the libraries, and you see already there are quite some external developments and libraries that we need to do to run that agents. The next thing that we are going to do is we also want to install Crew AI, because that's not usually available directly in Colab. It's still a very experimental project and library, and therefore we need to install it. And that's usually taking a couple of minutes until we have Crew AI installed. And what I will show you in the meantime is the Crew AI GitHub repository, because as I mentioned, it's an open source project. You can download it if you want to build your own agents and develop them further. Just go there, maybe clone the project, and then you can enhance it. And the general idea of Crew AI is this illustration here. Crew AI allows you to build quite some agents, a lot of different AI agents. And then these agents start to collaborate given a particular process and hopefully accomplish a task that you designed the agents for. All right, let's go back and see if our installation finished in the meantime. Okay, we'll see here there are a lot of libraries that have been installed. And again, don't try this at home. I mean, there are some errors here that we see. And this is, again, underpinning a little bit the cutting edge of the things that we are doing. We see here, in particular, that the pip dependency resolver is not able to resolve all the dependencies because of the libraries there, so cutting edge. But yeah, we will ignore that. But again, in a real-world audit setting, that's not what you want to do. Whenever there's an error, you want to follow up and see exactly where the error is coming from, right? Cool. Okay, so now we have Crew AI installed. Let's import it. That also takes a little bit because it's a heavy workload that the notebook now needs to handle. Right, so now we have Crew AI. And in the next step, we are also importing the LangChain OpenAI interface, very similar to what Harry was showing us, which allows us to interface also the latest GPT-4 model. We will do that because what we'll see maybe in one of the first results when we're using these agents, the open source models provided by Llama, especially the smaller ones, are not capable of performing these complex processes. So we need to have more sophisticated large language models to accomplish that. And one of the most powerful ones, of course, is GPT-4 at the moment. So we'll also import the LangChain interface. All right, so far so good. Maybe a quick show of hands. Who was able to do that so far? Okay, I see a lot of hands. That's perfect in the back. Thanks, you. Fantastic, that's great. All right, so now we're getting even more nerdy. We are now going one level deeper in our Colab Notebook environment. As I mentioned, we're really using it to the full extent. So the next thing that we are doing is we will install the Colab Pixar, which allows us to run command line commands or interfaces in the Colab environment. So we have a terminal now in a second available in our Colab environment. And we are using this to install Ollama. So if you're running this cell here, it will install the command line interface. And in the next step with %xterm, we get the command line interface available in Colab. And what we'll do in the command line interface, we will now use that to curl or to fetch basically our Ollama. All right. So now what's happening is it's downloading Ollama, the library that allows us, or the framework that allows us to install large language models locally, and installing this Ollama framework inside of the Colab environment. That again takes a couple of seconds. And in the meantime, what I want to do is I want to show you Ollama. So this is the Ollama library. It's actually a quite cool application because it allows you to, with very little effort, download large language models and run them locally at your machines. And they really interfacing a lot of different open source large language models, like for example, the latest Llama 3.2 vision model even, and a lot of other open source large language models that are available. So it's quite cool. What we will do in the next step, once we have downloaded it to our Colab environment, we will use Ollama to fetch the latest Meta AI Llama 3.2 model, and then hopefully have it available in our Colab without actually interfacing it using the API. So it's really in our Colab environment then. So now we have Ollama. And what we can do in the next step here is check if it's serving. So I'm copying this command, which actually says, okay, I wanna have Ollama be served in my Google Colab environment. So now Ollama is available in my Google Colab environment. I know that looks very intimidating or nerdy at the beginning because I mean, there's a lot of program terminal interfacing here, but it's worth the effort. Next thing that we're gonna do is now we have Ollama be served in our Colab environment. We wanna check, okay, what are the models that are available off the shelf by Ollama? By executing this command, Ollama list here. So that's what we have here now. Okay. So we'll do this again. But in the next command, we will now pull the latest Llama 3.2 3 billion parameter model. And now we are downloading the model from Meta AI. And hopefully after we downloaded it, it will be available in our Google Colab environment. So that takes a little bit because it's a 2 GB model. All right, this is the first time I'm doing it here. Let's see if it's working out, but it looks good. So now we have the model downloaded. And now if we run again our Ollama list, the latest Llama model should be available. What we can then do in the next step is we can check if the model is actually there. So we can run it. So we see here, okay, the model is running. And we could, very similar to what Harry was doing, also send a message to the model, and hopefully the model will answer our question, for example, that we are asking the model. But that's not what we are doing. We'll stop it here because we want to interface it. So in the next step, we make it available to Crew AI by executing this cell where we say, okay, from Ollama, we want to use the model that we just downloaded. It should be available via this interface with a temperature, maximum number of tokens, and a specific seed to get it a little bit more deterministic. And then we can ask it a fun prompt. For example, imagine you're an auditor reviewing an expense report, and an employee claims all expenses are legitimate business costs, and then we have a list of hopefully legitimate expenses, and send this to the model. And let's see if that's working off the shelf. Sometimes that takes a little bit because it's a large model and we are running it on the GPU, and we see this connection error. And that's what I'm meaning with it's all very experimental still. No worries. We can still go back. Usually the connection breaks at the beginning. So what we can do is we can just run xterm again. Launching xterm, we have the model already available. We just need to serve it. On our GPU. And then hopefully this could be resolved. Let's keep our fingers crossed. And let's see what's happened. Right. So now we have interfaced the model. We didn't send anything over the API. It's fully available in our Google-Colab Notebook. And we can do this with a lot of models now. So this is the response of our auditor. And I think it has some problems with some of the expense items that one of the employees claimed. But in general, I think it's a very good result. All right, now we know how we can use local models on our machines. And by the way, if you have, for example, a very advanced Mac or more powerful machine at your fingertips, this is maybe one thing that you want to do instead of maybe paying for an API or something. Install Ollama and then run the models locally on your machines. They're getting smaller also because they're much more quantized these days. So we see a tremendous velocity in that field to get the models available at our fingertips. Okay, cool. What I will do now in the interest of time, I will not run the agentic workflow using our local model because I know if I'm using that model, it's too small still for agentic AI. And our agents will start to get confused if you're using this model, if you use this model as a frame. So we'll go with a much more powerful model. We'll use GPT-4. And in order to do that, because Colab is still, in terms of the capacity, not able to handle GPT-4 models, we will interface it following the approach that Harry presented this morning. So what I will do is I will take my GPT key, put my API key here. Nope. And set my API key. Great. And then set it up in a way as I did before, and then use my LLM GPT and test it accordingly again with another prompt where I ask, for example, GPT-4 from an audit perspective, what is the meaning of life? And hopefully it will come up with a compelling answer for me. Let's see if that works. Nope, that's not working because I still run on the old GPT model. it could be a potential issue as well. Yeah. So that's, I mean, I was just showing it in Colab from a convenience perspective, but for example, as a supreme audit institutions as we are, we can't do that, right? We need to have it on our local machines. Absolutely. And that's a very valid question, a huge discussion actually over the last couple of months and weeks that we're having. But I'm now using the API again. We are sending back forth and back data, and hopefully the meaning of life from an auditor's perspective was convincing you here. Okay, cool. So now that we have GPT-4 available, we will use this GPT-4 model, and this model should function as the brain of our agent. So what we will do in a first step is we want to implement a single auditor agent. So this is our senior auditor agent, and its brain basically is our GPT-4 model, not the Llama 3 model, because I'm taking the shortcut here. And we will also equip this agent with a tool. And it's just a simple reading tool that allows the agent to read documents, PDF documents, text documents, and so on. And once the agent is able to do that, we can give the agent some tasks, for example, maybe answer questions based on a document, but it will do that completely autonomously. So we can send several questions and tasks to the agent, and then it will do that iteratively, maybe over a couple of weeks. I mean, if we run it in the background. So the first step in order to achieve that is we will implement the read guidelines tool. So this is just a tool that is fetching a guideline that I already uploaded to GitHub. And it's an organizational guideline about payments. And this tool can be used by the agent to read the guidelines or to load the guidelines. In the next step, I'm initializing this read guidelines tool. And then I'm specifying the agent. And that's the interesting part, because here we are using Crew AI to the full extent for the first time. So what we're doing is we are defining a senior auditor agent who has a goal to analyze comprehensive organizational guidelines and extract their main points. The interesting thing is really we can do this in natural language here because the brain of the agent is actually a large language model. The next thing that we can also provide, if we want to maybe prompt the agent a little bit further, we can provide a backstory, encouraging the agent, very similar from a positive prompt engineering sense, is saying, you're a skilled auditor known for your expertise in analyzing complex guidelines and so on. So that gives the model a little bit of a background. Then we also avoid delegation because agents can become very lazy. So if they see a task and they say, okay, maybe it's some of the first thing is, oh, I don't want to do it. I want to delegate it to someone else. So we say, no, that's not what we're allowing. So we're setting the delegation to false. We provide the Llama model or the LLM that we want to use. Remember, I would need to change this to GPT. And also provided the read guidelines tool. So this is what we do in order to set up the agent. In the next step, we are specifying the task of the agents or the task that the agent should accomplish. So what we want to do is we want to have the agent to summarize a given guideline, and it extracts its main gist in a very concise and a short manner for an IT auditor. So what we want to have perfectly, there's this large guideline, and it should provide a concise summary for the IT auditor. And the next step, hopefully the IT auditor can convert the small summary into, for example, a SQL query that can be sent to a database. So that's what we are doing here. So basically, we are specifying the task, and then we are executing the agent given the task. And now it's really cool and interesting to see. So we have the agent, the senior auditor. It has the task to summarize the given guideline. And now we see the agent in action. So we see the senior auditor agent, and this is the first thought that it has. So it thinks about, to start with, I need to understand the guidelines that I need to summarize. By using the read guidelines tool, I can access the guidelines. So this is all that the agent comes up with itself, because it knows, okay, I have this tool, here's my task, how can I combine both? And then it gets the tool output. It really starts to query the read guidelines database, gets the tool output, reads it, and it says, based on the guideline that I have been able to receive, this is my final answer. This is my concise summary. And of course, I mean, this is a mock-up, so it's a very simple task here, but I hope you can see the idea that's happening. So it says payments exceeding $100 US are generally prohibited, and there are some exceptions. So this is the summary of the guideline that the agent came up with. And you can imagine, we could run that with several tasks, several different guidelines, and it will continue and go on summarizing these guys and completely autonomously. So no, once you have set it up, no human in the loop anymore. In the next step, now that we have the single senior auditor agent established, we will also do the same thing with the senior IT auditor agent. And the senior IT auditor agent is very similar to my job because I'm an IT auditor as well at the Swiss Supreme Audit Institutions. So we are the nerds doing the database queries and doing the journal entry testing. So basically what we usually have, we have a reading tool that allows us to query databases. And we also equip this agent with a GPT-4 model as a brain. That's what we're doing here as well. But you could think of any other model. Maybe there are other large language models that you might want to use for the brain's agent, the agent's brain. So in the first step, what we're doing here, I'm setting up a mock database completely in memory. And this database has just 10 different payments, right? So that the agent can actually query the database. So this is my database. Now I have established the database. In the next step, I'm specifying a function that allows the agent to run queries on that database. So this is the tool, the run query database tool. So these are two code cells, basically, which allow the agent to run these queries. And then I'm instantiating this tool so that it will be accessible to the agent. Then again, using Crew AI, I'm specifying my agent as we see it here. So it's a senior IT auditor, and its goal is to convert an organizational guideline summary into a SQL query to determine guideline violations in the database of payment records. Has again a backstory. We are not allowing the agent to delegate its tasks because maybe otherwise, as we know, IT auditors are maybe also a little bit lazy from time to time. We want to delegate tasks maybe to our audit managers. And that's sometimes what's happening if we would run it without, for example, this flag. And we will give it access to our database query tool. So this is this agent. We specify the task again. So it should take the summary of the senior auditor and then execute or generate a SQL query based on that and run this SQL query at the database to be able to identify the summary requests that the senior auditor provided. We're doing here. All right, so now we have our senior IT auditor specified. And the last person or the last agent that is still outstanding is the manager auditor. That's what we're specifying here. And the manager auditor's goal is actually to create a comprehensive and compelling audit report that provide clear insights and actionable recommendations. That's what the manager should do. So we're also implementing that agent. We give it a write report task. And this is exactly how we want to have the report to look like. For example, it should have a summary, an introduction, the audit procedures that have been performed, findings, and other recommendations. And also run that. And with that, we have now specified all the 3 agents that we need for agentic journal entry testing. I'm just coming back to the original image. We have specified the senior auditor agent, the senior IT auditor agent, and the audit manager agent. And now what we can do is we can ask the crew or the audit team to work and solve the task that we have given it. And all we need to do is we take these 3 agents, specify the audit team the senior auditor, senior IT auditor, and the manager, and provide them the 3 tasks: the analyze guideline task, the query database task, and the write report task. And then kick off the work of the agent. And if I haven't forgotten to click on something, that should work. So now we see in the first step, the senior auditor starts to work, reads the guidelines, comes up with a summary. So here's the guidelines emphasize that all payments exceeding $1,000 are prohibited. Once the senior auditor has finished, the senior IT auditor takes over, knows his tasks, starts to test SQL queries on the database, thinks about how to perfectly generate these SQL queries, and then runs the SQL queries against the database, gets the 3 payments that are exceeding the threshold of $1,000 from the database, provides the results to the audit manager. The audit manager picks it up and writes a compelling audit report with an introduction, audit procedures, the findings, recommendations, and also the conclusion. So this is actually, I think the question basically boils down to, for us at least, to, at the moment, just to test it and see what are the capabilities. And the next question is then, of course, I mean, there are a lot of research questions associated with it. Does it make sense? When does it make sense? Do we want to give out that entire oversight? So this is, for example, one thing that I will speak tomorrow morning about, embedding this, for example, into an audit process. Yeah, there are definitely